Hello, everybody, and welcome to UXDX Online. So we're kicking off our online series, which is going to be a free series of events going out in 3 different time zones over the next few months, but all focused on the same thing that we always do at UXDX, which is trying to help companies shift from working in projects to working in product teams. And how we'll be doing that in this online series is that we'll be asking people to share their experiences and their case studies of how they're modifying and changing their ways of working to kind of figure out what the best ways of adopting to this new way of working around, moving away from that waterfall approach to more outcome-oriented teams and teams delivering for whatever the mission is of the company. Now, we recognize that there is no one-size-fits-all process. So we're not saying that everybody should move over from projects to products, but the way we best describe it is a functional team, and that kind of waterfall approach is the best in a low change environment. So if you aren't making many changes, there's no point having a team sitting there the whole time waiting to figure out what to do. It's best to just bring together a team, create them for what you need, and then disband them immediately afterwards. But a lot of us today are actually working in the opposite. We're working in very high change environments. And for those, it's best to have a cross-functional team who become real experts in their area, experts in understanding the customers, experts in understanding the business needs, and experts in understanding how each other works together. And for that, that cross-functional product team is the most efficient process. But this leads to a problem that in the waterfall world, there's kind of deep specialization. So you have your product, your UX, your design, your dev, your interaction designer, your QA, your data analyst, your data engineer. So could be 20, 25 people that get touched, or different types of roles that have some involvement along the way in a project. But a product team needs to be in that kind of sweet spot of around 8 people. So in order to do that, people need to shift to being what's known as T-shaped. So you still have your core area of speciality, but you know a lot more about all the other areas and what other people are doing. And that's what we're trying to achieve here with UXDX, is by sharing. Today, we're talking about product strategy. Next week, we'll be talking about UX processes. Following that, we'll be digging into design and dev. So we're always going to be looking at a different area to try help people build those cross-functional skills. And the last thing is that theory is great, and a lot of talks, they talk about the theory of something or how something should work. But often it's really the practice where the challenge lies. So that's why we always ask our speakers, try give some examples and try make a case study of it, so that it's not just purely talking about theory, but also about the practice and how to put that theory into action. If you have any questions, please reach out in whatever form you're using. So whether it's kind of the YouTube chat or different areas, or on our live chat on our website, please reach out there and we'll pass those questions on to the speakers. And there's always, if we don't have a chance, because sometimes we get asked too many questions that we just don't have time for, you can always go into the Ask the Speakers channel on our Slack, and we'll forward those on to the speakers. So that's enough about me. Without further ado, I'd like to introduce our first speaker for the evening, who's going to be talking about tools to drive product decisions. I think it was a longer title, but I had to shrink it down for the screen here. But I'd like to hand over now to Paul. Welcome, Paul.
Hi, how are you? Nice
Great.
to meet you, everyone.
See you there.
Yeah, I'm here. Can you hear me?
Yep.
How do I share my screen, by the way?
You should have a share screen option.
Here we go. Okay, perfect. Here we go. Hi, everyone. My name is Paul. Can everybody see my screen?
Yes.
So we're going to talk a lot about product management and how oftentimes some of the biggest problems when working in products, which is very iterative, and it's not a project waterfall type of approach. It's really a continuous deployment environment. How you need to figure out how to work with a leadership team who oftentimes blackmails you with tons of ideas, tons of improvements, tons of things that could eventually lead a product to just boil the ocean, having engineers basically just releasing features that don't add much value, really bloating the product and just not making it as valuable as it could be. So today we're going to talk a lot about strategic gridlock, which is how to basically avoid it. Because ultimately, when it comes down to product managers, user experience designers, as well as engineers, marketers, salespeople, leadership, everybody can have the best of intentions, but unfortunately, when you're building a product, you really have different working styles. The sales team has different working styles than the marketing team, who has different working styles than the UX and product and engineering team, and that really creates a lot of issues. And usually what happens in most growing organizations is that we have a tendency not to really understand what the product manager does, what the designers and engineers do. And this quote of Steve Jobs pretty much articulates the fact that we often tend to give to a lot more influence to the marketing and sales teams. They're often seen as the ones who are moving the product forward in terms of revenue, in terms of influence, and that basically gives them some kind of authority over what features the product needs to be delivering. So oftentimes when that happens, when you have the marketing team just winging it in some ways, or the sales team just winging it, the impression that gives inside an organization is there's a lack of priorities, and mainly because they're not product managers. There is no roadmap. They're just basically making decisions because their function of marketing and sales isn't really geared towards moving a product iteratively. It's actually geared towards doing marketing and sales. So why are they making calls on what features we're supposed to be releasing and what we're supposed to be working on and prioritizing? So oftentimes the gridlock that happens in most product organizations is that there is no priority. Who's making the call? That creates a lot of internal politics. The engineers want to work on their pet projects. The CEO wants things to be delivered. The sales and marketing are basically pushing for features the customers want or prospects want, and you have customer support that wants all the bugs resolved, and that creates a loss of direction. And the engineering teams often feel like they're being set up to fail. That includes the product and UX team, and contention develops where there is like what we like to call these days quiet quitting, right? The engineering, UX, and product team just become yes men. They basically just go forward with whatever feature people are asking them to work on, and that creates a lot of people issues, people leaving the company, wasted resources, and the product is not going to succeed. So what we need to come to terms with is the fact that a product will basically deliver value iteratively. And that iteration has to come through a gateway, which is the product manager. The CEOs will have a lot of features and shiny objects and R&D issues they want the engineering team to focus on. The customer success is going to want every single bug fixed, every single optimization optimized. And the sales team is going to basically take esoteric features that are being requested, that people that are prospects, they're not even actual customers, but their feedback somehow is going to have more value than the actual customers themselves. The marketing team is going to look at the competition, want the exact same thing, and the engineers are basically going to constantly complain about technical debt and having to remove that debt. So the product manager here, their role in all of this is to take everyone's request and basically try to identify what problems they're trying to solve. What are the problems? These are not about customer problems. Sometimes it's internal business problems. Sometimes it's about how we basically work internally, what is being done manually, what can be automated, where the customer is hurting the most, or where are we hurting in the customer sales cycle or the customer acquisition. So all these problems need to be understood, and the product manager's job is to take those problems and put them in a big parking lot. And a parking lot, the reason we call it a parking lot is because it's just where ideas go to stay, park, not to move forward. And ultimately, it's the product manager to determine, okay, which one are bugs, which ones are blockers, critical, major versus minor and trivial, because not every bug should interrupt the engineering time. But also, what are we going to, from these ideas, which ones are we going to do in 6 weeks, 6 months, and 6 years? Because oftentimes when the CEO asks for something or the engineers complain about something, that doesn't mean we need to immediately be working on it. There's always this short, mid, and long-term time frame. And in most software companies that we refer to as the roadmap. And the product manager is the owner of that roadmap. And product leadership, this is the CEO and the VPs and the directors of the company, have a particular responsibility of steering the product team towards a particular direction, right? But unfortunately, product leadership is messy. You got marketers, salespeople, CEOs, CTOs, CFOs, and that they get into meetings, and the opinions are dismissed, and conversations are basically taken on the side. And eventually, as a product manager, you realize that you're not adding much value, right? The first version of your product added a lot of value. Everybody was like, hey, the simple feature is so awesome. Customers are loving it. But as time goes on, as features get released, you realize that the value the customer is getting out of your product is just decreasing. So decreasing to the point where you really start looking at, am I really understanding my customer? So you do this customer understanding effort, and you release a bunch of features that really add value, and people are feeling it, and then the sales team comes in and adds a bunch of features that no one uses, and the value of the product goes down. And then you do another effort of really understanding this to your market, and that basically allows you to get nice one, great, the product is doing really well, and again, the marketers come in and they basically want a bunch of things figured out because the competition has it. You release the same features as the competition, and ouch, it doesn't work. And we continuously zigzag, and as we zigzag from adding value and removing value, the product adds more and more complexity, and eventually we start making revenue, we start moving forward. But imagine if there was a way of avoiding all of these bad decisions from happening, because ultimately this zigzagging is not really good for an organization. Sometimes you're working on value producing features, sometimes you're not. And a lot of companies will die because of their insistence on releasing features that don't add much value to the customer. So at Bain Public, we've come up with this idea that we call SOAP. SOAP is basically a hygienic thing where every quarter you need to basically move your product forward by making some key decisions on what you need to basically move forward on, and be honest enough on the things that you're not going to be touching on. And the whole foundation of SOAP is a product manager has to have some kind of a guideline. So the high-level strategic leadership of the company, that's the CEO, the CFO, the VPs and directors, need to pretty much on one page explain what the product is supposed to do. So that includes what's the big, hairy, ambitious goal of the product, the value for the customers, what are we going to ask the engineers to basically focus on? That's what we call the product mission. What are the various strategies the product needs to be able to achieve in order to differentiate itself on the market and not be cloned by competitors, and as well as what are the various tactics that align themselves with each strategy. So I'm going to show you an example with Tesla, where Tesla has a BHAG of being living in a zero emission world. The value proposition is really about competitively priced products that are energy efficient. The mission of the product is really to transition the world to sustainable energy through transparent R&D efforts. And what does transparency of R&D effort really mean? What aligns with this strategy here of basically anti-IP, all of our patents belong to you. They basically want to put patents out there to the world, and that's because they want to safely use the patents of companies using their own patents as a trade-off. So everything at Tesla has basically been defined strategically with particular tactics and particular metrics that allow the company to make decisions pretty regularly on what to move forward on and what not to move forward on. So in some ways, the leadership team of a company, again, that's the CEO, the C-suite, the directors, and the VPs, need to align on this high-level strategic baseline that basically brings you all the way from BHAG to the various tactics the company is going to use in order to accomplish what it needs to accomplish. And then the product manager, the UX team, the data and engineering team need to find various initiatives that align themselves to the tactics and the strategies that could potentially solve a bunch of problems through product releases that are basically going to allow the company to achieve its objective, its KPIs and indicators. So normal to say that every single feature of a product cannot be delivered at once. So any given quarter, based on this high-level strategic baseline that's been given by leadership team, the product team needs to go and present a number of initiatives and ask from the leadership team, look, guys, we have, let's say, $1 million of engineering firepower for the next 3 months to invest our time in. Is it possible for you guys to let me know which one out of these 12 initiatives we're going to need to move forward with? Here's how they align to the tactics and strategies. Let us know which ones we're going to move forward with. And the leadership team needs to have a way of making this decision and identifying the red ones that they're going to move forward with. As soon as the red ones have been identified, it's pretty easy for people to figure out what are the product releases in order to outbound communicate it to the customers, to the prospects and the world, that here's what's going to change about our product and what the engineering team and UX team needs to be working on, right? So ultimately, it comes down to the product managers to be able to take all these problems and to represent them as initiatives that solves those problems through the various features of the software, right? And that needs to be rigorously done. So ultimately, we've come up with the concept of a pillar. A pillar is basically a problem that you're trying to solve. So a pillar is one, if you look at it, all of these items here are pillars. So a pillar is basically an initiative that's being proposed by the product team that solves a problem, that has a particular objective, that will allow the company to achieve a key result, that there has a strategic importance for the organization to do so, and some value that it creates for the customer. A pillar is also a combination of a good old business case, this layer that you're seeing here, as well as a scope statement. So the scope could be divided into must-haves, nice-to-haves, and wish lists. And the idea for dividing it up is because you want the engineering team and you want the outbound communication through marketing and sales to be done based on things that you can deliver in a 3-month time frame. So the must-haves needs to be delivered in 3 months. The nice-to-have and wish list will be delivered only if we have time. It's a nice to have, right? So we ultimately get into the must-haves. That could be UX improvements. It could be technical debt. It could be some kind of unplanned features or deal-driven feature, but you'll write it down. And ultimately what you're asking to the leadership is, here's where we suck. I'm the product guy. I'm going to tell you guys, here's where we suck as an organization, and here's where our product can improve. Each pillar has a problem statement. It's a good old business case with objectives and key results. But also each pillar has scope, where if you look at the must-have and ask the engineers, how long is it going to take you to build this? Can you just give it to me in t-shirt size estimates, small, medium, large? You can get a pillar to basically show you, get an estimate against each one. So if you were to look at them one against the other, I should be able to say, well, I mean, given the amount of engineering firepower I have, let's try to do these 2 large ones rather than just doing this extra large one. That's a fine, constructive conversation to have, but that doesn't really solve the problem strategically. Basically, what the leadership team needs to look at is, present me all the pillars. We're going to choose the ones that make most sense for the organization. The best way to look at that is to have a decision-making framework, a bunch of questions the leaders need to ask themselves once these initiatives are being presented. So first off, what is the investment of resources? That's going to come from the must-have scope that the engineers are already put in place and defined. But what is the customer's willingness to pay? What is the customer's perceived value? And what impact is it going to have on our company? Let's go and get some data across each one of these pillars, so this way we can evaluate them on quadrants. So customers willing to pay versus the perceived value could be evaluated if we can get the leadership to basically express themselves on each pillar. If they've basically provided that data to us through meetings, then we can easily say which ones are going to have high willingness to pay and high perceived value, which are the core features, but the differential features are the ones you're looking for. That's the one you need to go after. But also you need to look at the impact that a particular feature is going to have versus the level of effort you're going to put. Because if you put too much effort on something that's going to have low impact, that's a money pitch. You don't want to go forward with that. So ultimately, the leadership team needs to look at what the product team is presenting in terms of a good old business case with scope and estimates, and basically make those decisions on what they're going to move forward with and what they're not going to be moving forward with. And the items that get discarded go into the near term, and the engineering team with the UX and data team can start working on the next quarter. Now, next step is to basically start taking those pillars that we've already agreed on for the next 3 months and breaking down what we call the scope matrix. And the scope matrix is now taking pillar must-have features and breaking them down into more detail. So for example, if I'm going to add functional features to pillar 1, well, I have workflow simplicity, I have personalization. Those are UX tasks, but the security fixes can go straight into Jira, into a ticket, because they're non-functional features that basically require the engineering team to deliver a firewall or traffic filtering. So once you have a decision from the leadership team on what we're going to do and honesty of what we're not going to do, it's easier for the product manager to break down the features, the pillars into its multiple subtasks, identify which ones are UX, which ones are non-functional, and be able to delegate it down to the engineering team for execution. Now, what's important is that we've basically fixed time to 3 months. We have 3 months to deliver this scope. Unfortunately, we might encounter some problems. One thing we know is that we've decided the pillars we're going to move forward with. Those pillars are aligned with the tactics and the strategies that give that the high level baseline that was set by the leadership team. So nothing is going to be a waste. We also know all the scope that's going to be delivered. So at this point, it's easier for the product manager to outbound communicate to the marketing team, to the engineering team, to the support team, and to the sales team what is going to happen with the product. Because it's pretty well known. If I look at all these details of what's about to happen, I could basically promise the following features are going to be released. So it's a lot easier for the sales team to go out and talk to customers about the future evolution of the product. It's easier for the marketing team to update the website to let them know of what's coming up. And it's easier for the customer support team to basically tell customers that future fixes are coming. But ultimately, nobody likes being told what to do. So you are a product manager and you're working with all these departments, and none of these departments wants to work with you. Why? That's just human, right? People are defensive. They're like, why did you make these decisions? There's a little bit of rebellion and all that. So what's really important is if the product's not going to move forward unless all these departments, marketing, sales, engineers, support, are aligned on why we're building what we're building, which comes back to the reason why we originally presented this particular project. These initiatives had business cases in them, and they had an alignment with the strategies and tactics of an organization. It's important for the product manager to remind people that ultimately we're not building anything here. We're trying to create the most value with the engineering resources we have. So the good habits that we need to do about roadmap completion is give ourselves the 3 months in order to figure out what are the other problems that we need to fix. You might not be happy with the decision the leadership team took today about features that are going to be released in 3 months, but I'm listening. Tell me what other problems that this product has, because I need to identify other opportunities for us to make decisions in the future. So what word that we like using is pre-wire. As a product manager, if you're basically releasing features iteratively and your job is to identify problems in order to get them dissected into business cases and approved by the leadership team, you have a certain responsibility to sit down with every single department and have these meetings before the meetings. That's what we call a pre-wire. It's basically informal conversations with marketing, with sales, with support, with engineering, with UX, in order to really understand the problems the product is having, and just make sure that whatever they're telling you, is it coming from anecdotal evidence or it's really data-based, they're backed with facts, right? And basically start negotiating and compromise and understand their way of thinking, because ultimately, if you're not trying to build a company where decisions are made by consensus. You're trying to build a company where decisions are made with consent. That means if the company judges that the particular pillars that were identified are the correct ones, it's not about getting everybody on board to say, I'm in. It's about making sure that everybody acknowledges that we are moving forward on this particular initiative because it makes the most sense for the end user and makes the most sense for the company. Marketing might not like it, sales might not approve of it, but we have consent to collectively move forward. So there's a difference between getting consensus and getting consent. Consent can only be gotten if, as a product manager, you are delivering pillars, business cases, and scope statements that align themselves with the company's strategies and tactics. And ultimately, product enablement, which is the output of these business cases that turn themselves into product features. The enablement is the outbound communication of that to the customers through customer support, marketing, and sales is going to be done by departments you don't control. So it's quite important for you to make sure that there is a process of how you're presenting these ideas, how these ideas are collected first of all, collected by these various departments, turned into problems, represented to the leadership, aligned with the high-level strategic baseline, and ultimately decided on what needs to basically be built and how the product will change. I want to thank you for giving me this 20 minutes to explain how we at Bain Public do things within organization. We have a way of working that is just best in breed approach to product management. And if you basically want to book a time with me and talk about it, we love learning about other companies and how things are. And the SOAP approach is basically this approach that I just described in the last minutes. Thanks, everyone.
Great. Thank you very much for that, Paul. That was a real kind of whirlwind run through everything.
Yeah, I was given 20 minutes, so I decided to just pack as much information as we can. There is a lot of thinking behind this, and it's the fastest I've ever presented it, but it's really interesting to see how organizations can rally after good ideas if they're presented strategically and with good old business cases.
Great. A few questions came in, so if you have a few minutes, we'll just ask a couple of them. I guess the first one that resonates with me is, this is brilliant if you do have that management and you have your lovely BHAG and you have your kind of, everybody's giving you the context and all of that. What advice do you give the product manager who doesn't have that level of clarity coming down from leadership?
Yeah, product management is very, very hard because doing your job is already tough enough. You need to basically, take features and build them and deliver them, listen to the customer and everything. So sometimes when you get into an organization where, I call it the bait and switch, right? You think there's a product management culture, there's a product-led culture, and you realize there isn't. There is no leadership process or approach to doing this. And you suddenly realize that your job is not only to do your job, but also implement this culture, right? And now you have two jobs and you're like wondering, should I stay in this company or should I move to another company where there might be a culture? And I can tell you 99% of the companies don't have a product-led culture. So just the grass isn't greener elsewhere. So it's important to realize that product-led culture can't just happen in a month or two. It's a process that maybe you can engage in over a long period of time, like a year or two, and to ask yourself, you know what, I'm just going to take these tips and tricks and start implementing this workflow within the organization. And eventually we're going to have this high-level strategic deck. But the most important thing I tell product managers is ask your CEO or your leadership team for a board deck. Any company that basically got funding through fundraising has a board deck that they present quarterly. Ask to see it, because once you start seeing that, you're going to get the high-level strategic baseline. It's just a question of taking those details and putting it into a framework that when represented to the leadership, they're going to agree with anyways, right? So it always comes down to asking the right questions to the right people, and most startups have those documents.
Awesome. And here's one that came in from Owen. Like the couple of points that you made were around kind of, if you break it down, so you have your pillars and you break them down, and then you can kind of see what's happening over the next few months. But what inevitably happens is things take longer than you thought that they would, or something happens, or you get that swoop and poop of the new initiative that just blows everything out of the water. So how should you deal with that if you've laid out your nice 3-month plan and then things start going awry?
So marketing and sales hate it when we don't meet deadlines, because they're already like doing their campaigns and they're promising customers that things are coming. So what's important is, you have the golden triangle. So like in some, you have the scope, you have the resources, and you have the amount of money you have, right? So what we're going to do is we're going to fix the time to 3 months. We're going to fix the amount of money we have to the engineers we have. And we're going to say scope is negotiable. So that's why we break the scope down into must-haves, nice-to-haves, and wish lists. So what we tell marketers and salespeople is we're going to meet the 3 months timeline because we're only going to deliver the must-haves. But if one of my engineers falls sick, for example, for a period of 4 months, 4 weeks or something, what am I going to do? I'm going to negotiate. I'm going to try to say, okay, what is it from my must-haves can I remove and replace it with a bunch of nice-to-haves that's still going to allow me to deliver? Because ultimately, delivering in 3 months something that's 70% of the value it originally was, or 80% or 90% of the value, is more important than delivering on not delivering at all, to be honest. So what I tell product managers is commit to the must-haves, and if the engineers over-deliver, great. take the nice to haves. Everybody likes candy, but if they under deliver, just keep negotiating and remove stuff from the must have to the nice to have. The fun part here is that you never committed to features to the leadership. You've just told them, look, we're going to solve these problems, and here's the business case, and here's the pillars. So as long as the pillar is delivered and the scope has changed completely, it's irrelevant. You're ultimately trying to achieve a particular, solve a problem and achieve a particular KPI. So if you achieve that KPI at 70, 80, 90%, no one's going to blame you. And what you can say is just re-trigger the, and say, hey, we're going to do version 1.1, and we're going to go and do that 30% in the next 3 months. So always deliver on 3 months by making sure that the scope is negotiable, but your timeline is fixed and your engineering resources are fixed.
Awesome. Well, thank you very much for your time, Paul. That was really, as you said, it was very quick, but very thorough. And I enjoyed it. Lots of questions coming in. So thanks very much for that.
Appreciate it, guys. Love it. Thanks for this opportunity.
Great. So up next, we have Rachel Ganz, who's a senior designer at Arup. And she'll be talking about thinking long-term, preventing prison for product users. So welcome, Rachel.
Thank you very much for that. I'm just, having been through the testing of the sharing my screen, I just need to restart the slideshow and remember how to share my screen again. Always the key thing.
No worries.
Okay. Okay, hi. So this is what I'm talking about, and I thought I'd say a little bit about where I'm from. So I work for an international company that has a head office in London. I'm based in Berlin, and I have a team which spreads from Montreal to Hong Kong. What Arup does is design and build things, incredibly complex infrastructure, bits of the New York Metro, the TV tower in Shanghai, the Bird's Nest Stadium in China, the Olympic Stadium in London, complex infrastructure and building projects, the engineering of the Sagrada Familia in Barcelona, if you know that. And here's one of the pieces of iconic design, which the Sydney Harbour Opera House and the structural engineering of the roof quite a long time ago. Now, within Arup is Oasis, and we produce the software that is needed to engineer that sort of structure. So who I am, I started out programming a very long time ago, did a master's in human-computer interaction and got fascinated by human error. And I've lived in Gloucestershire on a narrowboat in London, and I'm currently in Berlin. And what I'm concerned about is how we interact with the built environment and how we understand software models of it. So if you're working in the built environment, you've got things that change over completely different time scales. Anybody who's used the Internet of Things knows that the building will probably last a lot longer than the controls. And generally this is the set. The building lasts longest than the infrastructure. Mechanical stuff like fans, central heating, and then you get into the software and the systems, and then the interaction is the thing that changes fastest of all. Then when you have a building in a city, you suddenly have a complete set of risks. So, and a complete set of owners. They're the physical risks if the building falls down, and then they're the social risks if there are problems with the data and the systems. For example, famously, there have been baggage delivery problems at airports, and that's controlled by software. Now, humans interact with this stuff at so many different levels and places. So outside a single building, there's the environment in which it works, which it may be controlled by government, by local authorities, by culture. There are the owners, there are the people who use it, and then there are things like the emergency services that you may not think of as people who have to understand a building and have interactions with it. But whenever you create a building, you have to work out how fire engines can access it so that they can quench a fire. So in the physical world, there's a huge amount of interaction consideration. And here's a really simple example of a staircase. You may not think of that as a user interaction because we've known staircases for a long time. And about the only thing that can go wrong apart from you falling down them is whether you've got to the right staircase and whether you know whether you want to go up or down it. And to understand that, you have to know what the context of those stairs are in your getting from place to place. Slightly more complicated is a window. You have a lot of physical clues about what it does, but with windows nowadays, if your building has air conditioning or central heating, then a window doesn't just open and close, it also affects the environment for everybody else around you and may have significant effects on heating costs or cooling costs if you open it. So, but a lot of people aren't aware just how complex their building may be balanced. And a lot of buildings now stop people opening windows because it causes trouble, though it also makes people feel that they're less in control of their environment. Even more complex is a lift, especially intelligent energy saving lifts that are designed to calculate the most efficient way to manage all the people waiting and all the floors they want to go to. And there, you standing outside waiting for it may have no idea why the lift next door has stopped, but it's not going to the floor you want. I don't know if any of you have had this experience. I have had this experience. And again, it's because what is happening behind the scenes isn't visible to you. You may only have had a straightforward lift experience in the past. And beyond that, I remember a great story told by somebody who had come from the Northwest Territories of Australia, going to Sydney and seeing for the first time this terrible magic room. The doors opened and one set of people went in, the doors open again, and a completely different set of people come out. That's pretty frightening when you think about it. It's only because we have expectations of what happens in between that we're not scared. So those are the simple interactions with the building. Then as soon as you start, this shows a sewage treatment works and the controls there. Somebody has to understand this and understand what the numbers represent, what is important. And as soon as you get multiple pieces of data hubs and people interacting over even more complex systems, the challenge of keeping them informed about what they need to know becomes incredibly high. How do you show the system? How do you show the risks? How do you give them context? Okay, so this is what I do, and what the engineers I work with do is they're working with computer models of a building. So here is a computer model of a bridge that is designed for structural engineers to understand how the bridge will behave before they build it. And here's a kind of relatively similar bridge in the process of being built. So why do they build the computer model? Well, so that they can obviously take the risk out of building the bridge by understanding how strong it needs to be, how much it'll vibrate, what happens in hot weather. I mean, one of the issues with global warming is that road surfaces that were designed for one set of temperatures are now being subjected to higher temperatures, and they're not able to cope with them. Rails also, I don't know if you've had the experience that we had in the UK, that the trains had to travel more slowly because the rails had got hotter than they had been designed for, and they just couldn't take the speed of the trains anymore. How the bridge moves when people walk on it, how much it costs to build, obviously, but nowadays, as we are all aware of the issues around carbon or CO2, and how much is embodied whenever you use a piece of steel, whenever you use a piece of concrete, there is a carbon cost to that. And so the more efficiently you can build things, the less carbon you're releasing into the environment. So here is the software that I've worked on in the past. And as you can see, it's quite complicated. It's designed to describe invisible forces on representations of real material. So there you can see the bridge components. Here are all the different things that they can show as a result of the analysis. And yeah, it's not an easy read. This program has been around for around 30 years. What it does at the back end is incredibly powerful, and it is currently getting more and more stuff put in the front end as the engineering requirements become higher and higher, and the ease of use gets more and more difficult. But there are significant problems. Here you can see fairly obviously that there is a different result to the analysis. You know, there's a big blue bar there, but can you see the difference in the building? Nothing really obvious. How do you know what has changed? How can you show a user what is important? And this is the sort of data that the engineer will actually go and look at. They will pick through these numbers to try and work out what is happening. So it's how can we assist people to discover where problems are as quickly as possible. It's a 3D model. You can rotate it, you can look at it, but that also means that it can be incredibly difficult to find things. This shows just a screenshot, but imagine in the complexity of the 3D model, as soon as you turn it round, it becomes hidden. We can put a little bit of AI on it to capture bits that don't behave within an expected range, but how do we know if that is accurate? I mean, there are a lot of buzzwords around at the moment with software. Anybody who's mentioned Tesla will obviously have heard of a lot of them. Their key robotics, yeah, that's going to change the world for the better. Machine learning, obviously, artificial intelligence, which at the moment is mostly just still machine learning, but with a little bit of a fancy. Machine learning is basically statistics. Artificial intelligence is machine learning with slightly wider boundaries. Digital transformation, autonomous vehicles. Oh, I love that one. Data, yeah, they're all magic things, aren't they? And the key things that get involved with them is how closely does software match reality, and how well do people understand the difference between a model, as we saw of that bridge, and the reality of the bridge. How well do they understand the difference between what a self-driving car sees of the road and what a human driver sees? Because the reality is that software always has limitations because it has to work on a limited set of data. the data that Tesla or Google uses is vast, but it is not infinite. And the things that can happen out there are actually constantly changing, and the data will always be out of date. And as well as that, there is the fact that data may be wrong, or the data may be used in the wrong context, which is what's known as dark data. So one of the ideas was that we can automatically generate different solutions. You know, these show a whole set of different bridges that have been built by Arup, and get artificial intelligence to choose which would be the better one. But sure, that entirely depends on context. We can set those two priorities of using less material, using less energy, reducing carbon. But what has to use it? And where is it situated? And how do people want it? And the other key thing is don't kill anybody. As I said, doctors can kill people one at a time, engineers can kill people in their hundreds. If you build a bridge, as people will know who've just seen the pedestrian bridge in India that just collapsed and killed over 100 people. So maybe software can help stopping people make mistakes. Maybe we can create products that reduce error and I could just read the slides, but I think I'll skip it. But one of the problems is that mixing humans and automated systems can cause problems. This actually shows the collapsed building where Arup was brought in to find out what had gone wrong. The extension, the new bit, was absolutely fine and had been built according to spec. The building that it was attached to had been skimped on during construction. So the way it had been built did not match the way it had been designed to be built, with the very nasty consequences that you can see here. And so that's the thing, is that you can bring in an automated process, but there are always people around it. And people may, let us say, work around situations to find something that works for them. I'm sure none of you have ever done this. None of you have ever skimped on being a little creative on your timesheet, or left something logged in, ticking over to show you were working and capturing your data keystrokes while you did something else. But I gather that people do this, and they find workarounds around every system. So one of the key things here is who is responsible for a model of something in software? What is the data? Who owns it? And how can we ensure that it is correct? Again, there have been lots of little joyous stories about machine learning on data sets that did not represent the populations that they were serving. But more than that, there have been problems, small things, you know, with driver licensing issuing where somebody mistyped. And then once there have been people who've been issued with 2 addresses, there have been people and then have received double sets of bills. There have been whole sets of, everybody knows, of data problems. I'm sure, again, you've experienced them yourself. Mostly, those problems do not cause people to sigh, but in the area I work, they can. And so this becomes really important. How do you know that the data you're using is right? For example, here, I mean, you know, people can make mistakes when they're designing something, and this is true of software as well. They can design to the wrong code. For example, you're used to building something for an office, and then you're in Scotland, or Aberdeen, which is pretty granite, and then you have to build something in an area that's prone to earthquakes. The codes and requirements are quite different according to that. And then these assumptions where things haven't been fully communicated, poor planning, items constructed in the wrong order. I've seen that in software too. And then when people deliberately cheat. And does software actually help any of those things? Well, one of the things here is the fact that can you turn your mic off, please, Paul?
Yeah, sorry about that.
So what are the tests and the understanding people use to understand whether a process is trustworthy? So for software engineers, it's about whether they understand and process, whether it's tested, whether people understand the tests, whether they understand the code. And then there are things, you know, does it follow good practice? You look at the code and you have some understanding whether it's been well written, and then whether it's maintained. For a structural engineer, again, they want to know how it works, what are the inputs and outputs, and whether they can trust what it has done, whether their model of what the software is doing matches their model of what they'd be doing if they had the back of an envelope or a piece of paper or a calculator or a slide rule. So this set of quality tests is a little different from that set of quality tests. And so in engineering software, there is the model itself, there is how the model is designed, there is whether the results are reliable, and whether there is too much information for anybody to make a decision on. So another sad story, I don't know if you've heard of the Nickel Highway collapse in Singapore, where 4 people died. And this was to do with the way the software model had been used by the engineer. They assumed that the soil, the clay that the tunnel was being put into was drained. And dry clay is much stiffer than wet clay. Just imagine, you know, a potter's wheel. Where is the clay strongest? And they also used the way engineers analyze soil conditions is that they have various different mathematical models of how the soil behaves. Elastic plastic, which is that it behaves in a certain way until it reaches a certain level, and then everything changes, or more Coulomb or others. And you have to understand the right model that you are using for the right, for the analysis. So those mistakes, the reason I know this is, again, Arup was brought in to find out what had gone so terribly wrong. I'd also like to say that Arup does not produce the software that was used in this case. So there are 2 things here. One is the engineer using the software did not know his own ignorance or had been badly trained, but he made significant errors but how much did the design of the software assist him to make those errors? How did he know? How could the fact that he'd made the wrong choice be highlighted? You know, whose responsibility was it? Because here's an example. For an engineer in the textbook, something might have less than 10 degrees of freedom. Different degrees of freedom, in case you don't know, is the different ways things can move. But a real building can have over 1 million, because every joint in that building can move in 3 or 6 different ways. And then there is a gap between understanding the mathematical model and understanding and how it represents the building they're building. How do they control the quality of the data they're getting? And then how do they understand the results? How can you tell where there are problems in your model? How can you tell where your model matches the real world? So this is the piece of software that we released 2 weeks ago, which I'm really excited about, which is actually for geotechnical engineering. It's designed to assist you to draw the geotechnical strata, so the different layers of soil, to be able to set what material they're made of, to be able to configure the construction stages, and to be able to see the analysis results. And I mentioned earlier, so in this case, this shows a completed thing going through the 5 construction stages, and you can see how the soil is sinking and bending over the gap. This although this does have red in it, this has been checked for colour blindness and for accessibility. I just wish to make this point, as accessibility is one of the key issues and one of the key problems, in that approximately 1 in 12 men is colourblind. They may not know, quite a lot of men do not know they're colourblind. And if you are just using colour to show something as important as the effect of to show danger or the effect of behaviour on part of a bridge, then you just can't afford for them to not see it. So what are the key things from this? Well, that you have to understand what people do now to be able to create good software. You have to find out what people do already, what their processes are. How do what you want them to do with software map their understanding of the real world? Admit what your software cannot do. Understand that there will always be mistakes, misuse and abuse, and make what you have hidden, all your black boxes, as visible and understandable and accessible as possible. So the problem I have every day is, how do I convey the context, magnitude and importance of the numbers that engineers look at so that they don't kill anybody? There you go.
I don't think I've ever seen something end so dramatically. But yeah, no, it was a really interesting one. But I guess the question that I have is, you're always going to have a discrepancy. Like, the software is just relying on what people are feeding it, whether it's, like, as you were saying, big data, or whether it's just analysis of like a soil sample that they've taken themselves. So when you said at the end, kind of in the real world, accept mistakes, how do you try to work around that, like somebody has inputted something incorrectly?
Right. First of all, we have to ensure that there is the ability to iterate and check. So you never assume that somebody has not made a mistake. You always assume that in there are 1,000 engineers using this software. One of the there was a nice quote from the Chartered Institute for Ergonomics and Human Factors that 1 in 10 of every human actions is an error. It may be as trivial as reaching for your mug of tea that you've just moved 2 inches to the side of where you thought you left it. We're very, very good at correcting our errors, but we make an awful lot of them. So you should always assume that at some point, every piece of information is going to be wrong. I don't know if you...
And how do you convey that, though?
Well, first of all, engineers are highly trained on that they need to check. Secondly, you have the processes of getting them to check it, but also making it really, really easy to check. And again, we can use machine learning to flag a common range. But also engineers often want to go outside the common range. So this is one of the key interesting questions of you don't want to limit them, but you also want to flag, you know, did you really mean to do that? And where understanding what their priorities are. But yeah, you have to let them do things that are not standard. Because if you're working in unusual conditions, then you will have to do non-standard things. So yeah, it's a really, really complex set of problems. That's why I love working there.
Great. Well, we're actually out of time, so thanks very much. If anybody has any questions, just please ask them on any of the channels, and we'll direct the questions through to Rachel and Paul. But thank you both very much for your time, and really enjoyed your sessions. Thank you very much.
Thank you.
So that brings us to the end of our first online series. We are running these 3 times a week. They're all free, different speakers every evening. So please join in the time zone that works for you. If you want to keep up to date, please follow us on LinkedIn at UXDX, and we'll have all of the events announced there. So looking forward to seeing you again soon. Thank you very much. Goodbye.
Goodbye.